Hello students. So in this lecture we will begin with unit 3, that is embedded systems, and we will be learning about embedded C, its applicability to 8051, its pros and cons, that is advantages and disadvantages of programming in embedded C, plus the general structure of embedded C and data types in 8051 embedded C. Okay, so now before beginning with just we'll have a look over what is meant by embedded system. Okay, in simple we can define it as an embedded system is an application that contains at least one programmable computer and which is used by individuals and who are unaware that whatever the system they are using, it is a computer based system. Means whatever the user or the application which is being used, the user is unaware that it contains the processor or the CPU in it. Okay, then why the 8051 has to be programmed in C? So compilers produce hex files that are downloaded into ROM of the 8051 microcontroller. The size of the hex file produced by the compiler is one of the main concerns of the microcontroller programmers for two reasons. One is that the microcontrollers have limited on-chip ROM memory. Second, the code space for the 8051 is limited to 64 kilobytes. Okay, so using 8051, using 16 address lines, the maximum memory which can be connected to 8051 is 64 kilobytes, plus depending upon the versions of your 8051, they have the limited on-chip ROM memory. Okay, so the size of the programming language affects the compiled program size. So assembly language programs produce a hex file that is much smaller than as compared to the hex file produced by the C program or your embedded C. So programming in assembly is tedious as well as time consuming, whereas the programming in C is less time consuming and much easier to write, but the hex file produced in C is much larger than the hex file produced in the assembly language. The embedded C. So embedded C is a set of language extensions for the C programming language by the C Standards Committee to address common issues that exist between C extensions for different embedded systems. So embedded C uses most of the syntax and semantics of standard C, right? So in simple we can say that embedded C is an extension of your C programming. So and embedded C uses most of the syntax as well as semantics of the standard C. So some of the examples are like you have the main functions, variable declaration, data type declaration, conditional statements like if, switch, case, plus we have the looping structures like while, for, plus we have functions, arrays, strings, structures, union, bit operations. Okay, so already we said that embedded C is an extension of C language that finds its application in the embedded system to write embedded software or the embedded program. Embedded C was developed to overcome the limitations that exist in C language to write programs for various microcontrollers. Right? So coming to the general structure of embedded C program. Okay, so you can observe first field we have the comment field or the comments, then we have the preprocessor directives, then global variable declaration, then declaration of your main function, then we have the local variables, then we have the program statements or the instructions, right? Then you may have the user defined function, right? So the comment field, it indicates the purpose of the program, right? And whatever the comment you want to enclose, it has to be enclosed within the decimeter symbols. Decimeter means a forward slash followed by a asterisk, means whatever the comment you have, it has to begin with a forward slash and a asterisk symbol. Then we have the comment or a group of characters. Then the comment line, it has to end with a asterisk and a forward slash. Okay, and the comment line, it increases the readability of the program. So comments line can be on a single line or it can be on the multiple line, but it should not be nested. Okay, and the comment line can be anywhere in the program. The comment line can be written anywhere in the program. Okay, then we have the preprocessor directives All the functions of the embedded C software are included in the preprocessor library, like hash include register 51.h, or it can be our hash define. We can define some of the symbols. So these functions are executed at the time of running the program. Then we have the global variable declaration. This is a section where variables are declared globally. Means the global variable means the variable which is declared in one program module. Okay, if it declared as a global variable, the same variable it can be used in another program module. So such variables commonly we call it as a global variable. Then we have the main function. It is a user defined function, and every program has one main function from where the program is started, and it is enclosed within a pair of parentheses. Parentheses means the curly braces, right? Then we have the syntax. You can observe it. First we have the main functions. So the whatever the dash or the dots which are indicated, okay, just they are used to indicate the group of statements, and these group of statements in your main function, they have to be included within a pair of parentheses, right? So the main function, so in case of C, normally we say that every function has to return a value. Every function has to return a value. So if the main function, if it has to return a value, then it is declared by the data type as int main. Okay, so at the end you can observe we have the statement like return. So whatever the value has to be returned, it has to be returned here. Return means in this case we are using the type declaration integer. Main is a function, is a main function of type integer, and always this program will return a value of the integer type. So the main function which does not return any value, okay, it has to be written as white stands for null. White stands for null means main is a function which is not returning any value, right? So next we have the advantages of programming in C. So writing the program in assembly language is tedious because the user has to be familiar with the internal configuration, internal architecture of the respective microcontroller, that is your 8051, as well as he should be familiar with the instruction set, means all the mnemonics, whatever the addressing modes they support, right? That is the reason we say programming in assembly language is tedious as well as time consuming, whereas programming in C is less time consuming and easier to write, right? So the programs which are written in C, they are generally portable, means the program which is written for one microcontroller, okay, by using certain corresponding C compilers can be loaded into different microcontrollers, or the same program can be used for different microcontrollers. Plus the C programs are easier to modify and update, and code available in function libraries like Sin or POW like Power can be used while writing C programs. Then coming to disadvantages of programming in C, assembly language programs have fixed size for the hex file produced, whereas the C program, different C compilers produce different hex codes files. Means the program which are written in assembly language, they have the fixed size for the hex file produced, whereas the C programs the produce different hex files. So whatever the size of the hex file is there, it depends upon the compiler. Plus it is very difficult to exactly calculate the time delay for C programs, means calculating the time delay for C programs is difficult, right? Plus microcontrollers have limited on chip ROM memory, that is a code memory which is available, and misuse of data types by the programming in writing the C program, like declaring int, declaring the variable as integer instead of unsigned character. Okay, instead of declaring it as a unsigned character, if it has been declared as a int, then it will lead to larger hex files. And declaration of variables, the problem does not arise in the assembly language program. And the general purpose registers of 8051 such as R0, R1, R2, or it may be a register A or register B, are under the control of the C compiler, and those registers, they cannot be accessed by the C statements. So coming next to C data types of 8051. since one of the main goal of 8051 C programmer is to create the smaller hex files. So for that reason, a good understanding of C data types for the 8051 can help programmers to create hex files. So what are the different data types which are supported by 80, the C data types which are supported by 8051 are mentioned in the table, right? So the first one is your unsigned character. So 8051 is a 8-bit microcontroller. The character data types is the most natural choice for many applications. The unsigned character is an 8-bit data type that takes a value in the range of 0 to 255 in decimal, or in hexadecimal we can say it can take the value from 00 to FF, 00 to FF, and it is used in many situations such as setting a counter value or string of ASCII characters. So normally the C compilers, okay, then we have the signed character. The signed character is an 8-bit data type that uses the most significant bit, that is a bit D7. Okay, the MSB bit, it is taken as a signed bit to represent the value, whether the value is negative or positive, and the magnitude in and the remaining 7 bits they are used to represent the magnitude. Therefore, okay, so out of 8 bits, MSB bit is used as a sign bit, and the remaining 7 bits they represent the magnitude bits, and the values can lie anywhere in the range from -128 to +127, -128 to +127. So the signed character data type is used to represent quantities which have negative sign, for example temperature. So already we have come across two data types, that is unsigned character and signed character, right? So in case of signed character, you can represent the values anywhere in the range from 0 to 255, whereas if it is taken as a signed character, the values can be represented in the range from -128 to +127. So if the keyword is not used like unsigned or signed, by default it will be taken as a signed character. For example, just if you, instead of using it as unsigned, if you use it as CHAR, by default it will be considered as a signed character, and the values can be represented in the range from -128 to +127, right? Then we have the signed integer, unsigned int. The unsigned integer is a 16-bit data type that takes a value in the range of 0 to 65,535 in decimal, or in hexadecimal it can range, the value can be in the range from 0000 to FFFF. In the 8051, unsigned integer is used to define 16-bit variable such as memory addresses, or it is also used to set a counter value of more than 256. Since the 8051 is a 8-bit microcontroller and integer data type takes 2 bytes of RAM, right? And we must not use the integer data type unless it is required, since registers and memory accesses are in 8-bit chunks, and the misuse of integer variables will result in larger hex files. Therefore, instead of unsigned int, you can make use of unsigned character wherever possible, right? Then we have the signed signed integer. So signed integer is a 16-bit data type that uses the MSB bit, that is, if you take the 16-bit number from D0 to D15, the 16 bits, then the D15 it is used to represent the it is used to represent the sign of a number, if whether the number is positive or the number is negative, and the remaining 15 bits are used to represent the magnitude between the range from -32,768 to +32,767. If by default in front of your integer data type, if okay, the data definition like unsigned and signed, if it has not been used, then by default it will be taken as a signed integer, and the values have to be in the range from -32,768 to +32,767, right? Then we have the next data type, that is your S bit. S bit stands for your single bit. The S bit keyword is a widely used 8051C data type designed specifically to access single bit addressable registers. It allows to the it allows to access the single bits of the special function registers or your SFR registers. Then the next data type we have is in 8051 we have is bit. The bit data type allows access to single bit of a bit addressable memory of internal RAM memory having the memory address from or a memory space from 20 to 2FH. Then we have SFR. So this data type is used to access byte size SFR registers. It makes use of 1 byte as storage. Okay. So